6th grade. Today's lesson is part 2 of 13-8 perimeter. Yesterday's lesson was a little rushed. I sort of worked to video between Zoom 1 and Zoom 2 and was rushing things, and I left a few things out. So I want to follow up with sort of a part 2 video for that. In the classroom that happens sometimes, that we leave something out and then we realize that halfway through our classwork. It's one of the things I miss about not being in the classroom, besides you guys, is that I can't just sort of fix that when we're halfway through. So, a couple things I want to point out to you. The first is with these odd-shaped figures. One thing that we need to understand is that when they give us some of these measurements that you see in question number 7 in your book on page 463, you'll notice these dashes. So these dashes remind us that the length of the sides with the same dashes, the same number of dashes, are all the same. So for instance, here's a side that they label as 5 inches, and you see the 2 dashes. That means that this side is also 5, this side is also 5, and this side over here with 2 dashes, also 5. 3 inches here, there's 1 dash. That means that this is also 3, this is also 3, and this is also 3. So now we've got everything labeled. Now we're able to add and figure out perimeter. So of course we can add our 5s. We've got 4 5s there. That is 20. We have 4 threes? Yes, 4 3s as well. 4 3s is 12. So we add those up and get a perimeter of 32, and that was inches. Okay, so sometimes you need to recognize those dashes and then help yourself by labeling. Other times you might need to look across the figure and use that to help you figure out some of your distances. And I'll show you that next in number 8. Give me a minute to just draw that up on my board here, and I'll show you what I mean. So I'm labeling just based on the picture that is in number 8. 6 and 8. So my drawing is not exactly to scale, so you have to use your imagination just a little bit. But the sides that we're missing are these 2 right here, okay? So the length of this one, if you can imagine, would be the same as this one, because this, when I draw in the dotted line, is a rectangle. It's 12 here, so it's got to be 12 here. Well, if this is 6, then this piece across from it is also 6, which means then that this piece will be 6, because this 6 and this 6, where the dotted line would be, would make 12, just like that would make 12. Okay, and then we've got 8 here. If we had a dotted line going this way, this side would have to be 8 as well. Well, this is 4, so this is 4, that's going to make this 4. Now, remember, we're calculating perimeter, we're only doing the outside measurements to get the whole border of the figure. So now that we've got all of our outside measurements, we can add. Okay, so doing 10s here, we've got 4 and 6 is 10, another 4 and 6, 10, 12 and 8 is 20, add those up, and we get 40, and that was meters. So sometimes you've got to break up the pieces and look at them as rectangles or squares, and look at their opposite sides in order to figure it out. Also, number 3 up on page 463, I wanted to address that as well. There are 2 different ways that you can solve number 3. Now, it's just a square, okay, and each side is 20 1/3 yard. So it's a square, although I didn't draw it very square looking. Sorry about that. It is a square, so all 4 sides are equal, as you well know. So we could just do 4 times the side, but then there's the part about using the fraction. So 2 different ways that you could do this. You could do perimeter equals 4s, and so perimeter equals 4 times 20 1/3. Now you could multiply that, so P equals 4 over 1 times, we really need to make this an improper fraction, that's going to be 61/3. So we get 3 in our denominator, we get 244 in our numerator. We would have to divide there. You would get 81 1/3 is what that would be. Or the other thing you could do is you could convert the 1/3 to a decimal. So we would do P equals 4s, P equals 4 times 20. 1/3 goes to a decimal of 0.33. So 20.33. So then multiplying, if we drop that down over here, we get 12, carry the 1, 13, carry the 1, 1, 8, put in our decimal point, 81.32, which is very close to 81 1/3 or 81.33. So 2 different ways that you could work through that problem. Couple of reminders, I'm going to just sort of draw them in over here. You could always come back to this video. Couple decimal reminders. 1/4 is 0.25. 1/3, as we said, is 0.33. 1/2 is 0.5 or 0.50. 3/4 is 0.75. Remember that you can also figure those out by changing those over to an equivalent fraction that has 100 as its denominator. For instance, 1/2 changed over to hundredths is 50 hundredths, and then that's how this is written, 0.5 or 0.50. So hopefully that helps you. If you have any questions on that lesson, whether it's the work on 463 or your workbook page, feel free to email me and I'll help you through that. Sorry for leaving a couple of things out there. Also remember that if you're adding decimals instead of multiplying, you need to make sure that you line up your decimal points. When you're multiplying decimals like we did here, make sure you count over at the end the number of decimals you had in the problem, and that's how many decimal spaces you go over in the answer. Okay, next video will be today's lesson, which is a reminder and refresher on area. So we'll do that as a separate video. Thanks.